Okay, so let's see. Hi everyone. So today we are going to, well, just to recap, like last week, we essentially we made the document that describes um made the document that describes um well, I'll pull it up here. Let's see. Um Confluence. And um, so we basically made this image that showed kind of the layout of the pipeline using draw.io. And so basically what we're working on now here, ugh, why does it keep doing that? I don't want to see that shit. We're working on that like snowpack data. And so initially we're kind of creating that function for that. So that's primarily what I'm working on now. So yeah, let's go see that. So we'll just hop over there. So adding snowtel, so we had these functions. And then we had this request, so we're just gonna run through here. Then again, this snowtel data is then going to be part of this combined. Can I see this? Not in Firefox. Oh, it's HTML actually. I thought this was the. Anyways. So, metadata response object is not subscriptable. Oh, so response. So actually, yeah, we just need to quickly sync response.text. JSON dot load, maybe. Oh yeah, so I think it's dot loads actually in this. We should call this response JSON. So we'll just do that. I'll move that there. Or I can just call it snowtel. Or maybe just snow. There. String objects. No, so that's why I thought it was loads. Now it's saying it doesn't. No. So, yeah, again, we're just looking at what exactly format this is. Oh, so it's lat. So just call it lat, I think. Okay, so Okay, so yeah, we just need to, so here we basically need to get the latitude and longitude and calculate how far it is. The closest station. So I'm assuming they call this lon. So to do that, we're basically going to then do haversign. Lat longe 1. Lat close station, longe close station. Dis. And so we'll just do that. I'm just gonna print it for now. But here, then we'll probably also have an if statement. If dis is greater than threshold, which I'm gonna say if it's further, then let's just say 200 miles. Metadata file, snowtel equals none. Else I don't know if that's the best way to do it, but I don't know the merits of keeping this blank in the JSON versus putting none in. I mean, actually, you probably don't want to go none. Print. So yeah, I'll just do no close snowtel site. Distance is plus stra dis. And then otherwise we'll just put the snowtel as snow response JSON. We'll see if that works. Launch. You think they just call it similarly? I don't know. Fuck, what is this? Print snow response JSON. Oh, the LNG. I don't get the point of that, but name radians is not defined. Oh, I guess we need to use this other stuff. So from math, you import radians, sine, cosine, asine. I wonder if you can actually import all that. Wow, it actually imported. So let's try that again. Let's see what the print thing said. So it said the closest snowtel site was 3,857. Oh, that's kilometers. Well, in any case, so this actually returns this. Okay. In kilometers. So I might up that to 300 kilometers or something. Well, 200 miles to kilometers. I mean, it was an arbitrary thing anyway, so. But we could say, yeah, maybe like, we'll give a little extra leeway, like 330 kilometers. is what we'll use. I'll just right now put in my documentation. Threshold is max distance to associate SNOTEL site in kilometers. So just so people know, metadata path. That's pretty self-explanatory. Okay, so that's basically what the function will look like. And then if there is this station, then it would then, I guess, so let's just do a sanity check in this. North Rapid Creek, SNOTEL. So that's apparently the closest one, they're saying. So this one's in South Dakota. So that kind of makes sense. Looking at the map, well, I don't know if that would come up, but looking at the map, probably that would make sense. That would be the closest one to someplace in Maine. Because as we talked about, SNOTEL doesn't really go east of any of these states. Like, I think the furthest east is somewhere in South Dakota. So and then yeah, probably in like Great Circle Path, that would be the closest. So that does kind of make sense. And yeah, I would guess that was right around that distance. Like that would be yeah, at first I was thinking there was something wrong, because 3857 definitely would be too big for miles, but yeah, 2,396 miles sounds about right. I do think it's around 2,000 miles probably from South Dakota to Maine. I've driven that way quite a bit, actually, and that seems fairly reasonable-ish, at least. Yeah. So, in any case, so it looks like that function should work. We are going to use this cutoff, which is kind of arbitrary. And so, again, we really will only have snowpack data for these western states, pretty much. But yeah, at least it will be useful for them. So we'll close the output there. So that was part 1. Part 2 kind of is actually creating the code to get it on the daily basis. So essentially this code is what's going to add that to the metadata file. And then this code is going to be what actually then gets it. So once we have that in the metadata file, we're going to similarly for a SNOTEL station, get it for a specific date. So we're going to have a station ID, and we're going to have a start date and an end date. And yeah, that's basically what this function is going to do. So let's see with that. Get snow till date. I think their API was working. Let me go back to this. So again, we're gonna combine this data with kind of this core code that we already have functions with to call the USGS scraper and to call the weather station data, and then it's all going to be combined into this historical data frame. And we're going to run one large historical scrape. But so anyways, this function will have to support both the daily scrape and the historical scrape, which actually shouldn't be too hard, I don't think. But in any case, that's what we'll kind of write now. And so this will probably need some, my guess is return a pandas data frame. So we're going to get the response in JSON, but then turn it into a DF. And then we're going to have to fill it to be in the same hourly format as the percip and the weather data. So, but first we'll have to get it. So, pattern lines. So we'll go back to this API documentation. And yeah, like I said, this is where we saw the map. So yeah, basically those are the furthest east. So yeah, it makes sense that probably this would be the closest to Maine. You can simply see that. So it looks like that function, the haver sign, did look correct in that case. So get snow info for a station. This API is actually pretty easy. So we're gonna use this URL as a sample, I think, because we'll need to get it for specific date ranges, and then turn it into kind of a pandas data frame. So station ID. So again, we'll have to station. Okay, I need to remember what we were doing here. So the metadata file. So then again, we were getting in the scrape was this snowtells thing. I'm gonna look at this again, actually. So it looks like then we'll take this. Okay, so it looks like we take the triplet from this. So we take station information. Oh yeah, and we only want to probably append the first one. So I think we just do that. But then from the triplet, we basically then take the triplet, which would be station information, and then triplet. Actually, I don't think we need that nested, so I might just do this. So in this case, then the station ID would just be the triplet, But we're going to assume that whatever function calls this already supplies that. So, in any case, we're going to do, what is it, requests again. Yeah, so requests dot get base URL dot format and station ID, start date, end date. So we'll call this the base URL. And then the start date will be this. We'll grab this. So start date, and then the triplet will also be replaced here. So save that just for a second. So we'll do that. That's how we'll construct the URL. Then again, this will be the response. And then we'll do dot text JSON dot loads, and let's just see what that is. So let's do this. Oh shit, fuck that up. So get, so we have something like this. Alright, I don't know what format their dates are. Well, I see, that's why I should have recorded that before getting rid of the URL. But yeah, it looks like that. Okay. So it looks like that worked. And then this is a JSON array. It basically looks like it. Oh no, so there's data. So return JSON, and then we'd return data. Sync. Let's go back. Data, yeah, that's basically right. So crap, where'd that go? So yeah, we return data, and then so data, so that seems about right. And then but then we have to try to make that into a data frame, and then we would have to join the data frame with our other data. So but we won't worry about how the actual join would work now. Just the point of this function would just be creating a data frame from this. I don't think I've imported pandas in here, but we go then like import pandas as PD. I think there's pd.readJSON or something. Maybe. I'm gonna see if that works. Oh, that's from a file though. Pandas read in JSON dict. Read JSON. pd.dataframe.fromDict. See, I thought that's what we used though. pd.read. Pandas read JSON. Yeah, I don't know why that's failing actually. Oh, it's saying it's a list. It just thinks it's a list or something. Well, it is a list, I guess. Yeah, I mean, it is a list, obviously. Or wait, no, it's not really a list. Or is it? Or wait, no. Well, it is a list, but it's not, right? Okay, so I think we maybe just need to do this. Yeah, that works. Yeah, it's a dict. I thought that handled dicts. Oh, so there's pandas.dataframe. Hey, that works. Oh, why aren't they just using this? Okay. Okay, so read JSON won't work. No, that's just what I saw. pandas convert dict to data frame. So if I call dot items, or I don't know if that will work actually. Because no, but I thought that was like, wait, where's all the days? Oh, yeah, there, right? Okay, yeah, so each day. Okay, wait, yeah, so I don't actually want to use 0. Oh, that actually just worked. So that actually did work. Surprised that worked, actually. Any case, yeah, that did work. So it looks like that works. So that gets this function essentially done. Which is what I think what we want. 365. Blah, 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 blah. Snow depth. Okay, that's basically what we want, at least for now. So this is going to return this data frame. And then if people remember, then we had those other functions that combine the data that this will need to add on to, essentially. So, here we have this function, and that combines the data. So now we need to then have this join and then fill on the hourly rows with this data. So it's like this data frame, for instance. So yeah, where this runs, we'll get the combined DF, and then this combined DF will need to be further combined with the SnowTel data. So So yeah. So for this, we need to... Well, it's also time to start kind of redoing what the meta functions will be. So again, when the pipeline runs, it's going to need to run from, it's going to start by opening the metadata list. So we'll open that file, and then for each river, then it will load in the metadata and then pass that data to the relevant API calls. So that was kind of what we have to do there. So yeah, this like. So, I mean, I think what we actually might need to do now first, though, is create some of the... Well, there are a couple ways to do this, but it's not going to actually work with this example gauge, because, of course, this thing is... won't have the snowtail data. So, yeah, maybe we should get, like, a river from Colorado and use that as an example. So I might go do that now. USG. Oh, how about one of the rivers I actually have paddled? Maybe we'll get the Arkansas at Northup. So yeah, let's get this gauge. And then do this. So I need to get its meta file though then. Crap, my battery is dropping like so fast. I only have my shit charger, which like only like charges it like very little per hour, so actually a lot of times I think it loses charge. This is basically a phone charger. So yeah, stream could possibly be cut short then. Anyways, so yeah, I was gonna go get the metadata for this. I'd actually since like obviously the chart shows this, I created a new project for this on GCP. So actually I might start moving this stuff to this new project. Oh wait, it actually is charging. Maybe I won't have to worry about that. So we'll go on GCP. So I had another project. Okay, so yeah, this is what I'm gonna call this new, maybe the new data set. So, this is the new project I had created. But I still think, but the metadata is actually still on the old project, I think. So, I'm wondering if this is a good idea, maybe start using Terraform, because to get this environment set up. Maybe create a bucket. Yeah, actually maybe I'll start on that now, though it is kind of a digression. So anyways, basically Terraform is a tool for setting up cloud infrastructure as code. So that's the idea of Terraform. If you're not familiar with it, and I've actually already installed it on my computer, so I'm gonna quickly well, there's nothing ever quick about this. It's actually been a while since I've used it. I actually used to use it all the time at one of my previous jobs. But I'm gonna actually create probably a new repo too. That's like specifically for this. I'll call it like River Flow Infra. So, or actually that. Oh, I hate how these new like GitHub projects use main instead of like master. Like just bullshit, you know, political correctness at its finest. I'm gonna change that though. Or wait, I haven't created the branch, so actually I'll just create one on here first, I guess. That's fine. Select license. So I'll just create that in a second. Yes, see it used master. Okay, I'll go clone this now. Forget this repo. The bad repo. Okay, or maybe I can just. Yeah, I'll just clone this. There used to be a button where you could easily like clone or something. But there used to be a button, I think, that actually said open in GitHub desktop. Oh, do I want to do this under AI stream? Guess it doesn't really matter. Okay. Let's see. I'm gonna remove that since I'm not gonna use that anymore. Oh, so that's why it's not appearing. No, I don't want to create one. What? Should be easy to just clone a repo. Yeah, so shouldn't there be that on there? I mean, it's empty, but oh yeah, there we go. Open with GitHub desktop. There we go. Okay, cool. So I'm gonna create a branch called TF setup, where I'm gonna hopefully set up some of this shit. So we're gonna do is now go to the TF setup. This will be in documents. So I'll create a terminal there. Okay. So now I have to remember actually how to use this. So to set up GCP, it has been a while since I used this, but I'm going to remember. So yeah, you create a file called, that's your main.tiff. And we're gonna open that, of course, with Visual Studio. So now we go to this, and going to have to then get the name of this project. So project ID, provider Google, and then what is the region? Let's get the region. Okay. G-Cloud off. Okay, regions and zones. Yeah, I'm fine with it using central. That's fine with me. Okay. So, yeah, that's right. So what I'm going to do now, I don't remember if I have G-Cloud. Oh shit, I don't. So we can install it now. Mac OS X. Yeah, just get that. Oh wait, I do have an M1, I think. So it's this one I want to cancel. And yeah, basically actually Terraform we're going to use to deploy all the infrastructure on GCP. So all the buckets, and then all the like BigQuery tables, and then the Airflow processes through composer most likely. So this will just initially get it set up. I don't actually remember per se the exact thing. There's also this is like the tutorial I'm using to jog my memory, of course, just the basic one. I remember over time though you actually create like more like subdirectories that correspond to different infrastructure. For now, my goal is to just use this to essentially create a bucket. And yeah, I know I could like probably just create this bucket on 10 seconds using the console. But the good thing about having all of your infrastructure as code in Terraform is if this was like an actual production project, then like you might have like a staging environment or a test environment with all the exact same infrastructure. So by creating it as code, then you just apply to Terraform to like different projects, and it would create the exact same infrastructure in each. So, and then also if for some reason, I don't know, you wanted to recreate similar infrastructure, you just have the code for it. So yeah, I could create like a bucket in like 10 seconds. But this we're going to have all of our infrastructure created as essentially code that can be then readily and easily deployed and edited as code. So that's why we're going to be using Terraform. So it actually is very useful, but it does have a learning curve, and I haven't used it and I do know how to use it. It's been like I think actually a year or two since I've really deployed anything using Terraform. But in any case, I'm gonna refresh my memory now with it. So okay, I don't know what's going on with my computer. Yeah, I might have to 21 minutes to fully charge. Yeah, I don't think that's gonna happen. What's going on? This should be instant. Yeah, I mean, usually if your archive thing doesn't work instantly, there's usually something wrong. At least if you're on a Mac. And kill it. It's like, I don't know what was going on. What the fuck? This isn't that big of a file. It shouldn't take like 20 minutes to unpack it. What the fuck? Do you have too many windows open? Kill some of these I'm not using. Spotify. I don't think I'm using Safari. What the fuck? I've never seen Archive do this shit. I don't know what the fuck's wrong with it. Should take like 2 seconds to unpack it. Oh, there. It looks like it unpacked it there. I thought there was just a DMG you could install. I could have sworn they actually had a DMG or something. I don't know why the fuck they don't use it, have a DMG for this. Let me see. Oh. So it actually does want the higher directory. cd dot. I wonder if I'm missing files. Yes. 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 Google Cloud SDK. So this should work hopefully now. Let's open a new terminal. Okay, so it's at least recognizing it in the path now. So yeah, basically then it will come up with this account to off. I'm going to quickly black my screen while I do this, while I authenticate, but very straightforward. You basically just, authenticate and follow the prompts. So I just did that. Okay, so just authenticated there. I'm going to remove that terminal. Now go back to the other terminal. So normally when you do this, you start always with like the Terraform init stuff. So you'd run like Terraform init. We haven't added anything yet, but we just run that initially. So yeah, what we're going to do now is use Terraform to create a basic bucket. So this should be pretty easy. So, basically we go to this. What we're gonna do is, I thought there was an extension for Terraform too. Because there was one I remember that like did the highlighting. I don't think it's installed though. Yeah, that would be it. Okay. I'm going to close this and then reopen. I really should open this as a project. Hopefully this will like look right now. Okay, cool. So trust. That is my file. So cores website. Yeah, I don't know what that is. I don't think we need any of that shit actually. So we're gonna call this bucket. Well, this is the resource, but the bucket will be. Shit, my battery's dropping even more. Okay, yeah, I don't know how much longer my battery's gonna last. Yeah, I really need to get a new Mac charger because this thing. So, but we're gonna call the bucket. Flow data. I don't want the location to be EU though. GCP locations. So I'm gonna Google the locations. I assume most of the people accessing this bucket will be from at least somewhere in the US. GCP locations. Not that it matters too much, but I'm gonna throw it, I guess, US West 1. I mean, I don't really know where people will be ax. We could do North America. We could do Montreal, I guess, too, or somewhere. I'll just keep it at that. GCP bucket location. Or wait, no, maybe bucket locations are slightly different. Yeah, this is what. Okay, US West 1. Okay, that's good. Looks like it's a low CO2 one too. So location. And then with Terraform, you can usually find out what all these variables mean. So what does that force destroy mean? Project, location, storage class. So we don't have a website, we don't have a cores. Yeah, I think retention, logging. Okay, let's see. Terraform. I think we then apply. So I remember there's a init. Yeah, and so yeah, I think you also then would you would create different vars. Oh yeah, Terraform plan. So that should show you what's being added. And I think it runs some validation checks. So so this is, so it shows when you run that, it shows that this bucket will be created essentially. Truthfully, this is not, you would also probably not just throw this in your main. This would normally be in a subfolder.